So in this video, we are going to write a code for the monitor of our header design, and monitor is used to collect the response from the duty, and the response is generated when the data is driven to the duty by the driver, which we have already discussed in our previous class. And it will just collect the data from the duty, and it will maintain a communication with the interface, and then it will just send that data to the scoreboard to check whether the test have been passed or not. So we will begin with naming our class, and like our previous classes, I will name this class monitor. I want to keep it as simple as possible, so it should extend the UVM monitor class from the UVM libraries. And unlike driver and sequence, it does not have any parameter uh, for the transaction or the sequence item. So I will end the class. So after that, since monitor UVM monitor is a component, the very first thing we will do is to do the factory registration. And we will just write the name of the class inside. After that, we will mention a few things. The first thing that I would like to mention is the transaction, is the TLM port, and I will discuss about TLM port more in details in our upcoming lectures. So for now, we will be using an analysis port, and an analysis port can send data to multiple class or to multiple imports or exports. So to use that, you have to write UVM analysis port, and then it has one parameter, and that parameter is the that parameter should be the sequence item or the transaction, and the name of the transaction class is sequence item in our case, so we will write sequence item. And then you have to write a user defined name. I will name this one as, let's say, a port. And then uh, we have to create a handle for our sequence item, and I will call it T. And then these two classes, those are driver and monitor, are the only classes which interacts directly with duty. Hence, they have to maintain a sort of connection with the interface. So we have to use UVM config DB and specifically the get method to retrieve the interface. And it will be same to that of the UVM driver. We have to mention the interface to be virtual, and then we have to write a condition in which we will use the get method of the UVM configuration DB. So I will just write the instantiation to be virtual, and the name of the interface is add_if, and then we will name it. So I will name it VIF, and it is same as the one in the driver. So after we are done with this, the very first thing we are going to do is to create the constructor. And since UVM monitor is a component, it will have two formal arguments. I will name it same uh, as the name of the class, and the second argument should be UVM component, and I will keep it null. So inside this, the very first thing we will do is to call the constructor of the parent class, and then we will pass the same formal arguments. And then here inside the constructor of the monitor class, we will also create um, an object for the analysis port, and we will do this using the new method. Since it is not a UVM class or component or even the object, we won't be using the type ID create method for this. Instead, we will use the simple new method, and it should have two arguments. The first argument will be the name, and I will keep it same as the name of the instantiation right here. So I will name it import, and the second one is the parent, which I will refer to this monitor class. So after that, we are done with our monitors constructor. Now we will move on with our build phase. And the argument should be UVM phase. After we are done with this, we will create an object of the transaction or the sequence item using the create method present in the UVM libraries. So after we are done with the object of the transaction, we will move on with the UVM configuration DB. And for this case, we will be using the get method to retrieve the interface. It should have a parameter, and that parameter should be the type of the thing that you are retrieving using the get method, and that is the virtual interface. After this, using the scope resolution operator, we will write the get method, and it would have 4 arguments. The first one will be the scope, and scope basically says that this particular get method belongs to which class, and I wanted to limit it to this monitor class only, so I will use this. Second is the relative path, and I will keep it empty, and it should be passed as a string. The third one is like the handle name, and I will call it VIF, which is same in that of driver. And then the instantiation itself, which is VIF. So if the retrieval fails, and if it fails to retrieve the interface from the configuration DB, then it should generate an error. For that, we will use UVM error. And unlike UVM info, UVM error will have only 2 arguments. The first one will be ID, which we will retrieve using the get type name method. And the second one should be the message you want to print. So I will just print the same thing, fail to access the interface. And this will just return the name of the class, which is monitor, as a string. And there should be no semicolon after this. So that's all. We are done with our build phase. So let's move on with the run phase. And similar to driver, in driver, we were driving the data from the transaction class to the virtual interface. And in the run phase of monitor, we will be retrieving the response from the virtual interface. So let's begin. So the very first thing we will do is to use a forever loop, which is very similar to the run phase of the driver, because we want our monitor to be ready whenever the response is detected. So here is the important part. So here, the very first thing inside the forever loop is to write a delay, and that delay should be equal to the delay which is provided at the end of the run phase or the forever loop of the driver. So this delay basically indicates that it will wait for this time to it will first drive the data, and then before moving to the next transaction, to the next copy of transaction, because there will be uh, 10 transactions in total, because we are repeating our transaction and randomizing them for 10 times. So before moving to next transaction, it will just generate a delay. And monitor, uh, so basically it is waiting for the monitor to collect the response, and pass it to the scoreboard to check whether the sequence or whether the test has been passed or not. So monitor will just wait to collect the response from the driver, and before moving to the next sequence, everything will be done. So uh, the sequence only moves to the next one only when driver is done driving the data to the DUT, and it does not concern the sequence that whether monitor or the scoreboard has finished working or not. So for that reason, we are adding a delay, the same delay which we will use during the beginning of the run phase of the monitor, just just to wait for the monitor and scoreboard to complete checking the test. So that's why this test is important, and this test is important during the beginning of the monitor to collect the response without any mm, without any clock timings violation, which is not that important in our case since our design is combinational. Still, it is better to use a delay, a similar delay which will be used at the end of the run phase of the driver. So after this delay, we will do the same thing which we did in the driver, but it will be opposite. In the driver, we were passing the data to the DUT, and in the monitor, we will be collecting the data from the DUT to the copy of the transaction which we have created right here. So to do that, I will refer to each of the signals. So the input is A, and we will collect it from the virtual interface. Then the signal B, which we will collect from the virtual interface. So unlike driver, in which obviously we will only be driving the input signals, here we also have to collect the output so that we can pass it to the scoreboard to get it checked. And the output is Y. Yes. Also, take a note for one more thing. Here, unlike the driver, we are using the blocking assignment, whereas in the driver, we were using the non-blocking assignment, which is important to maintain the sequential behavior of the circuit. But in monitor, it does not concern us because we have given enough delay to get a proper response from the duty, and then we are only interested in collecting the data instantly. So here you do not have to use the non-blocking assignment here. So this pretty much concludes uh, our monitor. But just like every other class, I would like to add few more fancy things, and I would rather not call them fancy because they are important to see what is happening during our simulation. So just like this, I will write UVM info, and it is very useful to detect whether anything is wrong with the design or not, whether you are receiving the correct data or not. So we will use a simpler combo of UVM info and the print method. So UVM info should have three arguments. The first one will be, of course, the type name, and it is ID. And the second one should be the message. So I will say the following response is collected from the DUT, and then for this time I will give the verbosity as UVM none. And then we will just use the print method for the handle of our transaction, which is T, which will just print the entire members of the transaction or the sequence item, which is collected from the DUT. So yeah, I forgot to write one more thing, and it is basically the most important thing, and that thing is to declare a mean of transferring the data from the monitor to the scoreboard. And remember, we created an instance for an analysis port, which you can see it right here. Then we also created an object inside the constructor of this monitor class. Now we will use that thing right here. So to use that, you just have to write the instance, which is a port in our case, and then you will refer to a method which I will call write. And inside the write method, you will have your transaction, the handle of the transaction or object of the transaction as an argument. And that's it. You just have to pass the transaction which contains the response from the duty using this port and the method of this port. And then in the next video, inside the scoreboard class, you will declare the body of this method, the write method. So this write method is basically being used in the with the combination of this analysis port, and this is basically being used to maintain a communication between the monitor and the scoreboard, a means of passing the response from monitor to scoreboard. And then in the scoreboard, you will declare the body of this write method. And in our case, I will just write a, a reference model or a checker inside this write method. So scoreboard is going to be very simple. So stay tuned for the next video. Thank you.